more of a, you don't need to give an ideal answer, but just an intellectual curiosity. If really we need to get sharper than where we are today, all these models are good in terms of, reasonably good in terms of pattern recognition, needle in the haystack. If something has been done in the past, they probably can mimic it, right? That output can come through. So if you really need to keep getting iteratively closer to how we understand a situation, a scenario, how do you think data scientists, researchers need to think about training these models and evolving them?
Yeah, I think we've been increasingly seeing that quality of data, and it's not now, it's been from the time neural nets were formed, quality of data is extremely more important than the quantity of data. Right now, I think the way in which models are trained is a lot of data from the internet. We also see a lot of biases because of the data that is there in the internet. Problem number one, point number one is we need to find a different way of training these models where we concentrate on getting better data. There's been proof to say a 7 billion model performs much better when it was actually trained with textbook information rather than internet information, right? So we need to look at quality of data to be trained, that is being trained first. I think the second most important thing is we look at giving data to these models and just making them learn from it. Rather, another way of looking at training is for the model to go explore about what data it actually needs to explore. So it's more like how the child kind of learns. You provide it with a little information and then you figure out what is it lacking, and then it comes back with what is lacking, and then you train it with that data. In some sense, what happens is the quality of data improves because you're only giving it whatever it needs, and you don't create those connections which is not really needed, right? So that's another strategy. People are still working. There's a lot of research that is going on this field also, and there is of course symbolic AI, which is getting a lot more importance right now, which is added along with knowledge graphs and ontologies to make sure that there is sense to what data that you are training it with and not as just random set of text that you're training it with. But yeah, maybe all of these together will lead us somewhere. That's kind of the broad idea.
Yeah, maybe it goes back to a correlation that there is no one model, foundational model that probably will solve all your storylines. I think we will see a lot of these expert models, and interconnection between these models probably is the key, where models tend to leverage each other. Right, the way humans, we as human beings have learned and evolved with our ecosystem play, maybe these models are trying to create a community among themselves and learn from each other. And since you mentioned data, probably no conversation will be complete without talking about some of the best practices around data engineering. Like you already put it, it's not about the quantity of data, it's the quality of data. Because cost ROI is something that's very important in terms of putting these equations out. Just what you gentlemen, your thoughts around data engineering and best practices that probably you've come across.
Sure. So I think there is increasing amount. A lot of people when they start up, they kind of, their AI initiatives falls flat because they don't have the right data set, right? And we also heard that getting data sets is actually very, very difficult. And there are two broad strategies to think about it. One is you just take everything that is available and then you try to make sense of it later, versus you start looking at what is more important for you right at the start of iteration and then only use that information for training. I think both of these strategies are equally important depending on what is your source. If for example, if I'm taking like a big enterprise like Flipkart, they have huge amount of data and there is no point in trying to dump everything somewhere and then make sense of it later. It's rather better to make sure that they look at what is more important, take high quality data and train it, versus let's say there's a new startup like Kioskin where they don't have a lot of data. It probably makes sense for them to take everything that is available for them because they're at dearth of data. So I think first people have to understand that these models are only as good as the data that you provide them, because they are not reasoning engines and you're not training them with reasoning data, you're training them with actual data. So which means that you need to give them as much of data as correctly as possible, and they're only as good as the data that you provided in. iterating over these models and trying out different strategies becomes extremely more important than coming up with newer models, is what I would say. Because at the end of the day, there is a new model drop that is happening every week. There are different companies which are coming up with open source models. There are different strategies for extracting this information. So you should have enough engineering around iterating around this as fast as possible, and enough data engineering around it to make sure that enough data is available if you have to fine tune these models on a weekly basis, on a monthly basis and stuff like that.
Any stories from you on the cost part of?
I'll kind of build on what Anand said. For you to be able to decide on what data you want to eventually ingest, end of the day it works out to the cost factor. And we kind of follow a 3-rule policy. One is, what's the problem statement that you're trying to solve? And I think the most important question to ask is, how much do you think that people will be willing to pay for the problem that you just solved? And the third is that, do you have the relevant skill set and people and the time for you to invest in fine-tuning those models to be able to solve that problem and solve it in such a way that it is acceptable to the common man out there. So what we have really found out and talking to so many founders and others is, these 3 questions, if you, the day you find yes to all these 3 questions, I think you are bang on. Then you will automatically find the right data, you will find the right sets, you will find the right people, and then you will also work with the right strategies that we have, right from optimizing the data to ensuring that the data that comes in, comes out, everything is clean. I think that's very crucial. So we need to be able to have answers to these 3 questions. And at a slightly technical level, what we've also found is when people start discussing cost, essentially it's all to do with the latency, right? And latency, if I just try to break it down, there are 4 types of latencies that happens. One is the model latency. So it's super important that once you know exactly what problem you are trying to solve, you choose the right model. Don't choose a 3.5 or a 4 or 4 turbo just because the 4 turbo is probably the latest one. You don't need a 32K token limit. You probably are good enough with the 4K token limit as well. The second thing is, please invest in prompt engineering. People just copy paste stuff. End user will be an end user, he will copy paste stuff, right? And then, so typically we've also seen lab implementations wherein, there is a prompt, and then they just blindly go pick up data from their underlying data sources, from vector DBs, from documents, and the system message itself is 12,000 tokens. And then obviously the recipient token, resultant token is like 10K. And then they expect the whole cost to be under 5K. Sorry, it doesn't work that way, right? So please invest in choosing the right model, making sure that you have the right prompt engineering in place, you have the right implementation in place. The third thing is the network latency. See, as of today, while we've been trying to democratize this whole access to AI, the fact is this whole supply and demand is non-linear, right? I just want to make kind of ask you, as the people who are out there, see, we have seen a bunch of people who are genuinely trying to solve a problem, people who are genuine enthusiasts, and we have also seen a bunch of people who are just doing it for FOMO's sake, right? So you have a lot of problem because there's going to be a lot of noisy neighbors in the initial stages, just like you have a lot of people in the gym between the 1st and the 5th of the month, and then it's all empty. So try and figure out as to what category do you fall in, and make sure you choose the appropriate model. For example, between a PG and a provision throughput, choose what you want, what works best for you. And then also choose a region that's probably closest to you. So model latency, network latency, throughput latency. If we can address these 3 things, you will see that you have a far better control on the cost, and you also have a far better control on the data that goes in and the data that comes out. That's the day. I'm just sharing what we learned over the last 1 year working with multiple folks on how exactly do they manage and get the best out of LLMs.
Yeah, and probably my statement to end it would be that leveraging GenAI is cheap if it is cheaper than the very high value that it unlocks at the end of the day. But you would want to close the panel, here one very sharp insight that you want to leave the room with around GenAI and its evolution from here?
I think it's dusty, and I hope that it'll settle.
I was going to say something similar. So the hype has been generated. Now it's up to capitalize and make the best of it. That's my
Sure, and I would just end by saying that hype sometimes is required. I think the entire humanity curve gets triggered by these kind of hypes. There is definitely a leverage of it, maybe just boosting a lot of our engineering productivity or XYZ productivity. There is a lot of wealth to be churned from there. Anything that we humans do which are very repetitive, which have definitive patterns to it, which are mimicable, I think GenAI will just make it redundant, get our time and minds here back into creating a lot more innovations, a lot more IP. So I think we'll have a lot more free time to think and innovate. That's where I would leave it with. Thank you.
Hey, thank you very much. Thank you all.
Thank you guys.
So guys, any questions, please feel free. Everybody, but by the way, will be available later on. I'm hoping to make this entirely collaborative and interactive at the end of the day. We have one last agenda item and then we will actually open it up and make sure that we start collaborating all together. That agenda item is for us to share quickly some of our thoughts from the white paper. I'm going to ask Shivangi to come up to talk about the white paper. Actually, can I ask Anuradha, can you send me the QR for the, we're going to just give you the QR code so you can actually download it. And then please feel free to comment. So while she speaks to it, you'll see whether it's interesting enough or not. We'll give you the QR code at the end of her talk. For now, let me hand it over to Shivangi. So Shivangi is part of SenseAI and helps us find the right startups. So if you're a startup, this is the person to know in SenseAI.
Thank you, Rahul, for the lovely words. I'm Shivangi. I lead investments at SenseAI. And I would like to quickly talk about the white paper.